have the three problems that are solved by machine learning. So the three problems solved by machine learning are classification problem, regression problem, and clustering problem. So from what we explained yesterday is that whenever we have a scenario that has to do with getting an output that has to do with a class or a certain category, we're talking about classification. So the example we gave yesterday was identifying numbers. So we have 10 digits. So if we have a scenario where our machine needs to identify amongst the 10 digits, that will be a classification problem. So a classification problem, you need to understand that the output will be a function that determines the classes. So if you have if you determine between mangoes and oranges, so maybe a mango can look like this, and then an apple will look like this. Okay, so if you have to create an AI tool that can determine between, can distinguish, can identify these. So you're going to provide data of let's say we have 3 pictures, or let's say 1,000 pictures of apples and 1,000 pictures of mangoes in different shapes. So what will happen is that the algorithm will learn from this and create a pattern, because what we're going to do is we're going to tell the algorithm that this is a mango, this one is a mango, this one is a mango, and this one is an apple, this one is an apple, and this one is an apple. So basically, we're going to give the data some level. Now we let the AI learn, we let the algorithm learn from this data and identify certain patterns, certain similarities, to be able to classify this as apple and this as mangoes. So just about this scenario of identifying between this. So if I have 1,000 pictures of apples and 1,000 pictures of mangoes, how many output category will I have? How many? How many will I have?
Sir, can you please repeat the question?
If I use 1,000 pictures of apples to train my machine, and I also use 1,000 pictures of mangoes to train my machine in order to be able to distinguish between mangoes and apples. So how many categories will I have? How many outputs will I have?
2.
2, perfect. So because my algorithm is just following a scenario of finding out what is an apple and what is a mango. So it's the data, the 1,000 pictures that I'm going to use will just be data for the algorithm to be familiar with this type of data. And next time I bring a new picture of a certain fruit, my algorithm will be able to determine if it's a mango or it's an apple. Let's say I bring a picture of a banana. What will happen? What do you think will happen to our system? The system will look at the similarity of this banana and see if it's more likely to be a mango or an apple. So it's going to identify it as a mango, for example. Why do you think it's not going to identify it as a banana?
I think it's because it is not trained to identify a banana.
Perfect. So it does not know about bananas. It only knows about apples and mangoes. So this is what we spoke about it last time when we talk about weak AI and strong AI. When we say so far all the AI can only do what they were trained to do. So this AI was trained to determine between apples and bananas. So it will not be able to uh, to to find something else. All right. So now, with that being said, so we have that is a classification problem, and then we have regression problem, where we can have a lot of scenarios where the output can be any value. So it doesn't have to be a value of it doesn't have to be a certain category. And then the last one would be a clustering. So in a clustering, we basically gonna create it mostly with unlabeled data set. In the clustering, we're not gonna have this level and tell the machine that this is a mango, this is an apple. No, in a clustering, we're just gonna provide this data and determine certain classes. And the algorithm will choose these fruits and put them in one class. So based on their similarities. Okay. Um, all right. So any question on that? On the type of problem we're solving? Okay, so machine learning type. So now we have the type of problem that we're solving. Those are the type of scenarios that we can have. Now, how are we going to teach the machine? There is about three main ways of teaching the machine, right? So the main ways of teaching the machine, we have a supervised learning, just like human being, supervised learning. You learn things by having someone who teach you something. Or you can have an unsupervised learning where you're teaching yourself a certain skill. And then the third one, we have the reinforcement learning. Reinforcement learning is when you are learning by being corrected, by like you do it yourself, and then when you make a mistake, they tell you it's a mistake, then you learn from it. So the same way we do it with machine learning, we will have a supervised learning, an unsupervised learning, and a reinforcement learning. But sometimes, depending on how big our data are, some data can be trained in a supervised learning manner and other data in the unsupervised learning manner. So in that case, we're going to have a semi-supervised learning. All right. So what is a supervised learning? So a supervised learning will be when we're training with data that are labeled. What does it mean? It means that the example I just gave you there of mangoes and bananas. So whatever data we're going to provide to the machine, we're going to tell the machine what are the outputs. So basically, in the supervised learning, we obtain the optimal model. Remember what is a model? The model is the final formula which represents the AI itself. Okay, so we obtain an optimal model with required performance through training and learning based on the samples known categories. So we already know the categories. So we already know the mangoes and the apples. So we've already told the AI what is a mango, what is an apple. So the AI already know that. Okay. Then we're going to use the model to map all input to output. Okay, that's how we're going to classify. What does it mean? It means we're going to take every input and see how it contributes to the whole object being part of a certain class. You understand? So that is supervised learning. So in supervised learning, we're going to provide the data that are labeled. So we're going to provide data that we've told the machine what is the meaning of those data. So if you provide pictures, you want to identify, you want your AI to identify between dogs, cats, and tigers. So when you provide pictures of dogs, you will let your AI know that these are pictures of dogs. When you provide pictures of cats, you will let your AI know that these are pictures of cat. So your AI will have labeled data. So that's what we call That's why we call it a supervised learning, because all the data are labeled. So in the case of an unsupervised learning, it means we have unlabeled data. So our data are not labeled. We're not telling the AI what are the data. We let the AI discover by itself. Okay, so basically the learning algorithm directly model the input data set and creates a clustering. That's in the case where we're talking about the clustering. So clustering is a common form of unsupervised learning. So we don't tell the machine what type of data, what are we dealing with. We let the machine discover by itself and create similarities. So basically, when the machine will calculate the similarity between new samples and existing one and classify them by similarities. So we will look at, in the case of dogs, cats, and tigers, we just provide these data to the machine without telling him these are dogs, cats, or tigers. But the machine, we can maybe specify numbers of classes. We just want to separate them in two groups. So the two groups that will be created, maybe the machine will look at certain similarities and see certain sizes. So animal with a certain size will be put in the first group, with another size will be put in another group. So you find a lot of example of clustering when you think of your Netflix, for example, the type of movie they suggest to you based on what you've been exposed to. So they classify them in a certain group, even if the movies do not have the same, it's not the same type of movie, but because it's the same actor, so it can classify them in a group of actors or the type of movie that there is. Okay, so that's where we find unsupervised learning, right? So semi-supervised learning is only when we're gonna have a group of data, that an amount of data that are unlabeled and some that are labeled. Then, so basically from supervised and unsupervised, we can get semi-supervised. Okay, and the last one is the reinforcement learning. The reinforcement learning is a type of learning that is used to teach, for example, self-driving cars, robots, and all these things. So how does it work? It works based on a system of reward and punishment. So basically, we create what we call an agent, and then we let the agent take a certain action in a certain environment. And then the agent needs to accumulate rewards. Okay, so the difference between the reinforcement learning and supervised learning is the teacher signal. So in a supervised learning, we provide data that are labeled. But in reinforcement learning, we introduce what we call the teacher signal. So we introduce a system of reward and punishment. So what we will do is we will give, in the case of dogs, cats, and tigers, we will let the machine, we tell the machine, okay, what we do, instead of telling the machine that is a dog, what we're gonna do, we'll let the machine predict. If the machine say it's a dog, if the machine get it right, the machine accumulates a point. Let's say, for example, +1, the reward is +1. And then the machine do it again. It's identify another picture, a cat. If it's a cat, it adds +1, until it will restart that. We can ask the machine to restart it 1,000 times. And if the machine does that 1,000 times, and every time it comes back to something that never gave a reward, the machine will change and take a different action. And the machine will learn from these data by getting this reward. Okay, so that's reinforcement learning. Okay, so those are the three types of learning. So we have supervised learning, unsupervised learning, and reinforcement learning. All right, so now let's look at supervised learning. So this is an example. So we're going to have data. So we have different features of the data. Feature one can be whatever we want. We have all the features. An example can be here. So we have the first feature is the weather. The second one is the temperature, and then the wind speed. So we have these as the data that we were given. We're given data where we say, okay, what's the weather? The first sample sample 1, 2, and 3. So the first sample where we have a sunny day with a warm temperature and a strong wind, and then we tell the AI, based on this data, we are going to enjoy sport. Yes. The second sample, rainy, cold, fair, output, no. Sunny, cold, weak, output, yes. So this is a supervised learning because we told the AI about the level of the data. And then we let the algorithm learn from this data. When it learns from this data, the supervised learning algorithm will learn from this data and be able to start now predicting. Okay, so what does it mean? This means that now, next time that we come and use this AI, if we just, the AI is going to ask us what's the weather, what's the temperature, and what the wind speed, and the AI is going to tell us what's the output if we're going to enjoy or not. Okay, so in a supervised learning and a supervised learning example, when we that one is a classification problem where we have to decide if it's a yes or no, so we choose in a class. But we can also have a regression problem, such as to determine the average temperature on Tuesday by looking at previous day data. The temperature on Tuesday can be any number, it's not a certain class. That's why we consider it to be a regression problem. But this regression problem has been used with supervised learning because we use label data. Okay, so we gave dates. This is Monday. There's a temperature, so we already had data previously. Okay, so the dependency between attribute value is discovered by expressing the relationship of sample mapping through functions. So through different functions, we're going to take all the data that we have. If we have 10,000 pictures, so we're going to see and create a pattern in the 10,000 data that we have. Okay, so some question can be, how much can I benefit from the stock markets next week? So to solve this and create an AI that can determine this, it's a regression problem. What's the temperature on Tuesday based on previous day? That is a regression problem as well that we're going to be solving with supervised learning. Another supervised learning algorithm that is going to solve a classification problem. We try to determine if we're going to have a traffic jam on a certain road during morning rush hour. So that answer can only be a yes or a no. So it's a category. So we're gonna have that. And that's how are we gonna know that? We're gonna supply the machine with previous data. What has happened in the past? In the past, on certain days, we have traffic. And then the AI will be able to tell us if we're going to have traffic on the next day. Okay. All right. So remember, in an unsupervised learning, what's the difference? We have no label. We just have clusters, which are groups of data. Based on the similarity of this data, the machine will be able to classify this data in a certain group based on the similarity. So in an unsupervised learning, we have data, but we don't have label. So we don't have an output for those data. So the machine itself is gonna classify them based on internal similarities. Okay. Okay, so these are examples of unsupervised learning when you talk about clustering. So basically, we need to understand that the machine itself will look at the data and classify them based on the similarities, as you can see in this drawing. An example can be to determine which audience like movies of the same subject. So because if the Netflix, the AI behind Netflix can identify that people in Johannesburg like a certain type of movies, so they're going to classify them in a certain class of those type of movies. And if you are in Johannesburg, you log into your Netflix, they will suggest to you certain movies based on the data that they've collected from that area. Okay, so All right. So semi-supervised, as we said, it's just a bridge between supervised and unsupervised. So if we have certain data, out of all the data that we have uh, some that are labeled and some that are not labeled, then we're dealing with semi-supervised learning. Okay, so the last one would be the reinforcement learning. Remember, we said we create an agent. So an agent is put in an environment, and the agent will check the status of the agent, and the agent will take certain actions in that environment, and then we're going to reward or punish the agent. So you basically, let's say, for example, you creating a video game, not creating. If you're playing a video game, and that video game you have to reach somewhere, so you have to reach this location here, and you are here. When you're playing, you go somewhere there, and then you lose, game over. The next time you're going, you're gonna avoid that area. So you're gonna try and go a different area. And if you pass, and then you move again, you get to this level here, you lose. So next time you're going, you're not gonna go this way. You're gonna go this way because you went further. When you get here, maybe if you lost here, if you get here, there's another route, you're gonna take another route until you get to the destination. So what have you done here? Every time you go into play, you will remember that this is the wrong way and this is the wrong way. So you're going to avoid this. That's exactly what we do. So we create a system. We create a system of reward and punishment. So we let our AI take its own action, and then we reward it or punish it. So this is used more in uh, manufacturing of robots, self-driving cars. So these are the type of reinforcement learning. An example can be when we're dealing with autopilot, should it brake or accelerate when the yellow light starts to flash? You understand? So when we look at that, for example, when we're creating the system, we say whenever there's a red light, we're going to punish it, and wherever there's a green light, we're going to reward it. You understand? So reward and punishment just mean we are adding a certain score to a certain score, and the machine will try and accumulate more of the reward. And the more it's trying to accumulate the reward, the more it's learning from the data. Okay, any question? Any question? Any question so far? Any question, guys? Any questions so far? All right. So now, remember now what we need to do. There need to be a process in machine learning. So the first will be data collection. Remember, we need data because without data, we cannot create any AI tool. Because whenever, no matter how good your algorithm are, without data, you're not going to do anything. You need data. So the first step will be to collect the data. The second step will be a data cleansing. That means we need to make sure we have the right data. We need to clean the data. After we've cleaned the data, now we're going to do what we call a feature extraction. We're going to see from this data, what information are we going to use? What does it mean? It means you want to identify between mangoes and apples. How are you going to do it? You're going to provide pictures of both fruit. So we collected all these pictures. You collect 5,000 mangoes and 5,000 apples. Now, you've collected the data. So the next step is data cleansing. Data cleansing, we need to make sure, are all the 5,000 pictures of mangoes and 5,000 of apples, is there any picture of a banana or another fruits or some oranges that will disturb this learning process? Do we have the wrong data? Do we have the wrong sizes of pictures, different sizes? Need to be same sizes. So that will be part of the data cleansing. So the data cleansing will make sure we are using the right data. If we confirm we are using the right data, we now go to a feature extraction, and then we're going to see what are we going to use as a feature. A feature can be maybe the size of the fruit, can play a role to determine if it's a mango or an apple. A feature can be the color of the fruit, the shape. Those are features. So once we select the right features, then we're going to train the model based on those features. After we train the model, we can now evaluate the model. If everything is fine, we can deploy the model. It means that we can post it, we can use it, we can do anything that we want to do with the model. But if when we are on the level of model evaluation, we fail to evaluate the model, it's not performing well, then where do we go back? We go back here. Did we use the right data? Did we clean the data? So we restart this process until we can get the best. All right. So features extractions are very important. So when we talk about it in detail, we're going to see how there is algorithm that can help you get the right feature for the right scenario. Because sometimes you may end up getting the wrong feature. Let's say you want to use, you want to determine something to unlock a door, the face of a person. You cannot use the person hair as a feature because people can cut, a person can cut the hair. If they cut the hair, what's going to happen now? You understand? So you have to be very careful when it comes to features extraction. How does it play a role? Like there is it's like, for example, you say a bus is traveling at 20 kilometers per hour, and the bus will travel for 20 minutes. And then you say, what is the name of the driver? Does the name of the driver relate to the speed of the bus? No. So that feature is useless for that scenario. Unless you want to tell me something about the family of the driver or some other detail that can make me realize what you're talking about. So that's exactly what you need to understand as well in machine learning. Do not use features that will not have any sense in terms of the scenario that you're trying to, that you have. All right. So we need to understand when we have certain concepts. When you talk about the data set, so the data set is all the data that we have. So basically, it's a collection of data that we're going to use for machine learning tasks. That's what we're going to call a data set. So when we're telling you which data set are you going to use, this is the data set, there's a data set missing, or whenever you hear the term data set, you need to understand that is just a collection of data which is being used. Okay, so each data record is called a sample. So if I have 10,000 pictures of dogs, it's a data set. And each picture of a dog is called a sample. Okay. So now we're going to have what we call event and attribute that will reflect the performance or nature of the sample in a particular aspect. So which those events or those attributes of this sample that are going to affect the performance of this learning process is what we call the features. That's what we say, we need to choose the right features. So anything that is going to reflect the performance is called a feature. Okay, so now in the data set, whenever we use the data set for training the model, we're gonna call those sets training sets. And whenever we talk about data that we're going to use to test, we're gonna call them test sets. Okay, so now when we're using this training set, which are our data set, we need to understand sometimes you can hear a term such as learning, right? So when we talk about learning, machine learning, it's the process of creating a model from the data. So we're creating a model from the data. So we let the machine go through the data and get familiar with the data. And that is called learning. So we can say the machine is learning. Okay. Okay. So this is a typical example of the data. We're trying to determine the prices of houses. This is the label. So we have three features that are being used: the area of the house, the school district, and the direction. So these are the features being used. So we are now given a data set. This all is a data set. And each one is these are samples. Sample 1, sample 2, sample 3, sample 4, sample 5. Now we're going to divide them. So we take four of the samples that we're going to use for training. So which will be called the training set. And then we're going to take one, which we're going to use to just test what happened during the training. That will be called the test set. So usually what we do, you can have 10,000 pictures or 10,000 data. What we do, we'll take, it's always a good practice to take about 20% of those data and use them for testing. Okay, so 80% of the data I use for training, and 20% I use for testing. Okay, so yeah, so we take this now. So from this training data, we're going to take this, and remember, this is the level that we have. We have this district, we have house prices, and then this sample is going to be used to see, to test. Okay, guys. So now, guys, what type of learning are we going to use for this scenario? What type of learning are we going to use for this learning, for this scenario? What type of learning are we going to have there?
Supervised learning.
Yes. So we have supervised learning. Why? Because we have labeled our data. Okay. So that's what we're going to do. So now it's very important now to process our data properly. So after we got this data, we were given this data, we need to go through a data cleansing, which is the data processing. So in the data cleansing, which is part of the data processing, now in this case, now we're going to look at whatever that can affect our model. Because if your data, you don't have good data, you're going to get a bad model. You understand? So if let's say, for example, you're trying to determine between cats and dogs, but you provide pictures that are blurry, pictures that are in the wrong size, and all those things. So that is going to affect how your your AI is going to perform. So let's look at data cleansing. So data cleansing, it means we will need to look at the data. If there is missing value, we need to fill them, you know. And then we have what we call a data dimension reduction. So we will look, sometimes we don't need so many data, because sometimes so many data are just going to disturb our AI. Just like a human being, when you learn so many things, you end up not mastering anything. So we will do a data dimension reduction, and then we have data normalization. Normalization, what does it mean? We reduce the noise and improve the model accuracy. So when you're dealing with pictures, for example, a data normalization can have to do with changing the size. When you're dealing with voice recognition, it's maybe adding some background noise so that the AI gets used to be used in an environment where there's noise. You understand? So things like that. So the data pre-processing level is very, very important. Okay. So data cleansing. Remember, most machine learning process, the features, which are usually numeric representation of input variable that can be used in a model. So these features that are going to be used will need to be clean, right? The data need to be clean by looking at the features and getting the right feature. So we need to do, as part of the pre-processing of the data, it involves data filtering, processing of lost data, processing of possible exception errors, abnormal values. Okay, so for you to understand that, I'm going to give you an example. Yeah, so we have something like this. So we'll avoid what we call dirty data. So when we talk about dirty data in machine learning, it means that the data that we have some irregularities. There is maybe noise, inconsistency, incompleteness, there's missing values, incorrect records, those are dirty data. So this is an example of dirty data where we were given ID, name, birthday, gender, and then check if the person is a teacher or a student, the country, and the city. So these are the data that we were given. So when you look at this example here, you see here we have an invalid duplicate item. We can see the IDs are moving as 111, 222, 333, 444, but here we have a duplicate 555. So when you have data like this, it can cause problem. So this is why these data are dirty. You have another example here for the birthday, you have the incorrect format. So all your data, if you're using dates anyway, they need to have the same format. And then here, gender we had M and F, but here we have A, so an invalid value. Okay, and then here we have is teacher, right? So if someone is a teacher, then they will have students. So this one is a student, a teacher, that means one, they have 15 students. If he's not a teacher, they don't have students. But here we have someone who is not a teacher, but they have students. This is an attribute dependency. So this attribute here depend on the answer here. But now we can see we have the wrong data here. And here we have a misspelling of the country. And here we're talking about cities. There's a missing value, and there's a country instead of a city here, which is a value that should be in another column. So this is an example of what we call dirty data. So this is the reason why we have to do a pre-processing and make sure we clean our data before we can actually use them. Okay. All right, guys. Yeah. So tomorrow we're going to talk about, after pre-processing, how we can use the data to to train the machine. But for you to understand, as a part of pre-processing, it will depend also on the type of what you call that, the type of scenario that you have. Another example can be, for example, when you're dealing with words in natural language processing, where we're dealing with uh, AI that has to do with word, reading word and things like that. So those words need to be embedded into mathematical numbers. So we'll talk about certain libraries that are used, for example, word2vec model, BERT model. So these are certain models that can be used to convert these words into vectors so they can go. Because remember now, uh, everything needs to go through mathematical calculations. So if you're looking at a scenario such as what we spoke about here, this is a word: Ireland, Ireland, Iceland, Spain, France, Germany, Italy. So these are words. How will the machine be able to do mathematical calculation to create a pattern here? These needs to be, the machine need to convert this into mathematical vectors. So these features will be converted to certain values, but we're going to talk about it as we're moving forward. All right, guys, any question? Any question? Any question before we can call it a day? Any question, guys? Any question? Are you guys? Because I've seen there's a few people who sent me the result already with big data. So yeah, so we're done with this AI class. The next class will be tomorrow. Okay, guys. So is there any question? Any question? Any question on your mock exam, big data exam?